So we are still doing the hypothesis testing, and we are here to discuss about chi-square test. Test of homogeneity. It is used to test whether the data is homogeneous or not. What do you mean by homogeneous? Suppose I have two machines, machine 1 and machine 2. Machine 1 manufactures 100 Coke bottles and machine 2 also produces 100 Coke bottles in a day, for example. Homogeneous means I'll pick only those manufactured by machine 1 and I'll do the analysis. Or I'll pick up only those Coke bottles from which were manufactured by machine 2 and then I'll do the analysis. If I combine these two, and out of these 200 if I pick up a sample, then that is called as non-homogeneous. It will become heterogeneous. Right? This is what is homogeneous. Homogeneous means I'll pick only from a specific set. So this kind of data. I have male, I have female, right-handed and left-handed. Right? What analysis can I do? So chi-square test can also be used for goodness of fit to check if the samples follow a particular distribution or not. But this would not be covered here. We will cover this in MBB or Master Black Belt. So chi-square test provides two statistics which can be used to determine if the variables are independent or is there any association between the variables. Those two are a chi-square and a p-value. You look into two statistics. Chi-square is a measure of the differences between the observed counts and the expected counts. For example, I'm expecting 100 marks in my exam. Observed might be, you might have in reality got 95. That is observed. So observed versus expected. What is it that I'm expecting, but what is it that I've observed in reality? Next comes chi-square test. Chi-square test is used to determine the p-value which decides whether the variables are associated or not. If they are associated, it is called as being homogeneous. If it is not associated, it's called as non-homogeneous or heterogeneous. If the p-value is less than or equal to alpha level, if p is less than or equal to alpha, normally we take it as 0.05. Then you can conclude that the variables are associated with each other. If this p-value is greater than 0.05, then you can conclude that the variables are not associated, or you cannot conclude that the variables are associated. Alright. But there are few assumptions even before we get started with chi-square test. Assumptions are that the sample must be randomly drawn from the population. If this is my population, suppose this contains details of all the people who possess iPhone 6 in the world. If I'm picking up a sample, the sample must be randomly drawn. That means I have to do simple random sampling, SRS. This is considered to be the best mode of sampling. I close my eyes, I blindly pick up sample and then I'll do analysis on that. This is what is expected. The first assumption of chi-square test is this. Second thing is data must be reported in raw frequencies, not in percentage terms. Provide me the raw numbers, don't give me the percentages. And the measured variables must always be independent of each other. Then there will be values or categories on independent and dependent variables. Right? These values or categories must be mutually exclusive and exhaustive. Mutually exclusive means, suppose flipping a coin, I might get head or I might get a tail, right? These both are mutually exclusive. If I get head, I won't get tail. If I get tail, I won't get head. Exhaustive meaning, if my experiment contains both, or if I'm giving equal opportunity for both, that is called as exhaustive. It's covering all the possibilities. Observed frequencies cannot be too small. If they're too small, you cannot carry on your chi-square test. So you need to have sufficient number. We have to do this actually using Minitab. We'll do that. So this is just an example of testing the homogeneity. Sales for products for 4 regions is tabulated. Find if the gender and regional sales are dependent or independent. So is my sales dependent on I being a male or a female? Yes or no, that we have to find out now. This is how you write the hypothesis. Proportion 1 equal to 2 equal to 3 equal to 4. That means for males, sales in east equal to west equal to north equal to south. There is no difference kind. Alternate hypothesis says at least one proportion is different. At least one is different. So let me open the Minitab file. Okay. All right. So this is the row total. What did I do? I just added all these numbers 50, 142, 131 and 70. Then I add these two, male and female, 50 here and 550 here, thereby I get 600. That's the column total. P-value is less than 0.05. I reject null hypothesis. This implies that there is an association between sales by region and gender. All right, let me move on now. So let us do this exercise also. We are given another exercise. Are females more likely to be right-handed compared to males? So let us see whether we have that Minitab exercise file or not. I don't think we have, but I think I can enter it manually into the Minitab and see. Control N will help me open a new worksheet. So here is what I'll write. Right-handed, left-handed. Are females more likely to be right-handed compared to males? Yes or no? For that we are doing this. Here I have male. 429 are right-handed, 28 are left-handed. Total is 457. Female 443, 21, 464. Here also I get a total 872 and 49. Now this is the exercise that we have to do. Again same thing, I go to stat, I go to tables, I go to chi-square for association. I select only right and left-handed. I remove this east, south. All right. Yes, this is in C1. Statistics. All right. Okay. p-value is 0.557. Greater than 0.05, you accept null hypothesis. The moment you accept null hypothesis, you are telling that all are same. All the proportions, I mean male, female, right-handed will be equally same. Equal number of people are right-handed when it comes to males or females. Yeah, that is what you conclude. All right, let me go to this. Okay. Until now we have seen what should we do when y is discrete and x is continuous, or when y and x both are discrete. What if both are continuous? What should we do? That is what we are up to now. If both are continuous, first thing is you check the relationship. You use scatter plot to check the relationship. Scatter plot looks like this, right? X and y, right? Then you put numbers, you see the direction of those numbers, etc. This scatter plot does not quantify to what extent the relationship is between the two variables. In order to quantify the relationship, you go to the correlation analysis. This is a technique to quantify the strength of relationship between the output and input. Y is equal to f of x. What is the strength of relationship between y and x? You can quantify using correlation analysis. You use something called as correlation coefficient. Pearson correlation coefficient, which is represented by small r. After this, if the strength is also good, then you go ahead with the regression analysis. It is a statistical analysis technique to identify functional relationship between an input and an output. Functional relationship means I'll write y, for example, suppose it is my sales. Sales is equal to 45% of advertisement expense plus 55% of another mode of advertisement. So in this way I come up with some function which will help me predict the output variable using some regression equation, which can give the value of output for any given input values. For any given input values I can do it. All right. So let us briefly discuss about this correlation analysis also. Correlation coefficient is represented by small r. It's represented by small r. It is a value between -1 and +1. It is depending on whether the relationship is positive or negative. It will be close to 0 if there is no relationship. If it is like this, then r will be close to +1, or we can conclude that there is a positive relationship. If the line is like this, then you say that it's a negative relationship. But if it is close to -1, you say there is a strong negative relationship. And if it is 0, then there is absolutely no relationship. So this is what we conclude. Correlation measures linear relationships. Never ever compute correlation coefficient for non-linear data. So linear means data should be looking like this, somewhat like this, right? This direction or that direction or like this. Right? Or it can also be like this, straight line, right? But it should never be like this, parabola kind of. Or when you represent data, it should not look like this. Getting me? Linear means it should be straight, that's it. Apply plot data to check that relationship is linear. Plot data means you can do a scatter plot. You'll come to know whether the relationship is linear or not. Next thing is correlation does not determine causation. Just because two variables have a high correlation does not mean one is causing the other. Yeah, that is very, very important. There is a correlation. Correlation may not be causation. For example, in summer, many people eat ice creams. Okay. And ice cream sales versus your temperature, there is a correlation and also there is causation. I agree. But it seems that eating more ice creams and number of sharks attacking people on the beaches, the correlation is high. This is a classic example to explain the difference between these two. It seems the sharks attacking people versus you eating more ice creams, there is a good correlation, but there is no causation. You eating ice cream, how is that related to shark attacking you? Right? So there is no causation. So correlation does not determine this causation. Next thing is the correlation coefficient, which is represented by R, is very, very sensitive to extreme values in data. Watch out for these to ensure that the model is fit or the model fit is good. So if you have numbers 1, 2, 3, 4, 5 and suddenly if you have 100, this 100 is obviously an outlier, right? For obvious reasons, it is an outlier. So these kind of extreme values are going to influence your coefficient, correlation coefficient. So you should be sensitive to this. You should be able to identify these. An example is given. Sorry. Plotting population of India, number of cars running on roads of US over a period of 10 years. This may have a significant correlation, but there is no causation between the two, right? Population of India increased significantly over the last 10 years. Number of cars in US also have increased. But is population increase in India related to cars? There's no causation. But there might be a high correlation, which we do not know. So find the correlation coefficient between sales and advertisement expenses and determine if there is a strong relationship between the two variables. That is the example that we are doing now. So let me open that file. Okay. Let me open this file. There is something called a scatter plot that we have to look at. If you have any doubts, you can probably stop me, Anuj. So I'm assuming that you are able to grasp things and I'm just proceeding further. Okay, fine. No. It will be very easy, Anuj. Don't worry. It's just the context, that's it. It's just the context. All this will be very easy. Identify Y, X, job done. You in Master Black Belt will discuss only on those problems, so you'll become an expert. So between sales and advertisement expenses, I need to see whether there is a relationship or not. First thing I do is scatter plot. Let me do a scatter plot between sales. Sales is Y, X is advertisement. I click on OK. Tricky. It's very tricky. But by looking at this, I feel that there is no correlation absolutely. But With naked eye, it would be a little difficult. So, this is about scatter plot. It just gives an indication, but it will not. What did I click? It's recorded anyways, but I went to graph and I clicked on scatter plot. Yeah, that was the first thing that I've done. Next, I go to stat, basic statistics, correlation. Why am I doing this? I'm doing this because by looking at the graph, I was not really comfortable in deciding on what is the strength of the relationship. So I just click on this. I see what is the relationship between these two. I'll go with Pearson correlation, though there is Spearman also. Oh, we have already done chi-square test, Anuj. It's recorded actually. Yeah, we have done it. Yeah, so these are the values that I'm getting. No problem. So let us discuss about the output. Output is mentioned here. This particular R value is negative. If you see, here is my Pearson correlation coefficient. It is minus. Minus means it's negative correlation. What does that mean? As in how my advertisement expenses increase, my sales is going to decrease. That is what this negative sign says. But as a thumb rule, if this value is closer to 0.85 plus or minus 0.85, then I can conclude that, yeah, how is it? Sometimes it happens, right? You try to spend on wrong advertisement. The world is moving towards digital, but you might invest still in paper ads. You might be circulating pamphlets. We don't know. That might be a scenario. So positive or negative 0.85 means there is a strong relationship. Now with the negative sign, we can conclude that there is a negative relationship, but the value is far away from 0.85. So the relationship is not at all strong. It is a weak negative relationship. Next thing is p-value. It implies we accept null hypothesis. Always null hypothesis says what? Everything is okay. These two are same. There is no relationship, right? Sales and advertisement, null hypothesis says there is no relationship. Yeah, so we are telling that yes, there is no relationship. Absolutely. Even the negative correlation says there is a weak correlation. I mean, you cannot even claim that that is a close relationship. Even a scatter diagram was telling so. When we looked at a scatter diagram, even that was speaking on those lines. All right. Okay, let me just go to the next slide. First, scatter. Do the scatter plot, check what is the relationship. In order to identify the strength, do the correlation. Then only if the correlation is strong, go ahead with the regression. In our case, correlation wasn't strong, so we are not doing regression for that particular exercise. Let us do it for another exercise if at all the relationship is good. So here is the question. A chain of stores wants to see how effective their advertising and other promotional activities are. The company has collected data from 50 randomly selected metropolitan regions. In each region, it has compared its own promotional expenditures and sales to those of the leading competitor in the region over the past year. There are two variables each of which are indexes, not dollar amounts. Dollar amounts are not given. Some index, some calculation is given. Promote. The store's promotional expenditures as a percentage of those of the leading competitor. Sales is store's sales as a percentage of those of the leading competitor. So sales you're giving as a percentage in comparison to the other competitors. Promotions also, you're giving the expenditures in relation to the other competitors. Now the company expects that there is a strong positive relationship between the two variables. Between my promotional expenditure and sales, my company is expecting that there is a positive relationship. So that regions with relatively more expenditures have relatively more sales. However, it is not clear what the nature of relationship is. They're telling it is strong, but they don't know what is the nature of the relationship. So let us do a simple exercise. Though my company is telling that there is strong relationship, I want to again cross check using Minita. We will do that. First you need to identify what is y and what is x. If both are continuous, obviously you will have to follow this path. Step 1, scatter. Step 2, correlation. Step 3, regression. That's it. Simple, straightforward. Yeah, expenditure is continuous, sales is continuous. Absolutely. Yes, yes. Okay, is this open? Yep, I think it's open now. So, no, is this the one? No, I think. Now it has come up. I don't know why it's taking so much time. All right. Promotion and sales. Is there a correlation? So I go to scatter plot first, come first. First I need to do scatter plot. That's it. Simple, as simple as that. I click on OK. Sales depends on promotions. So X and Y. By looking at this, can you comment, Anuj, whether there is positive correlation or negative correlation? Can we at least comment on that? Negative. Why negative? No, let me do this again. So you're a little confused. So let me go with the regression line actually. Sales, promote. Now Anuj, the line has given you some indication, right? Positive, absolutely. There is a positive correlation, fine. But what is the strength of this correlation, positive correlation? We don't know. Let us check that also. Go to stat, basic statistics and correlation. Promotion and sales, between these two, what is the strength of the correlation? It is 0.673, which is okay, all right. Not strong, but there is a positive correlation. That is what we can conclude by looking at this value, 0.673. Yeah, there is a relationship. There's a positive relationship, not strong positive, but there is a positive relationship. That is what we conclude. All right, now let us do the regression. Only if it is okay, we proceed actually. Go to regression, fitted line regression model. So this path is given in our deck also, PPT also, but let me click on this. What is response? Is response Y or X? Anuj, is response variable Y? Absolutely correct. Good, good, very good. So what is Y here? Out of promote and sales, what is Y? Sales. Good. Your understanding is quite clear. What is a predictor? Is it Y or X? X. In our case, in our example, is it promote or sales? It is promote. Absolutely right. Then I go to graphs. I want all the 4 graphs in one. Then I just simply click on OK. I get 2 things. We will discuss graph in a while. So first, let us go to the regression analysis part. Here the p-values are less than 0.05 for variable constant. Constant is coefficient kind of, and then promote. Promote is our x. For both of these things, x value is less than 0.05, which indicates that both constant and promote are statistically significant in defining your sales. In defining your sales, they are significant. There is something called as R squared. R squared value, you always look into adjusted R squared. We will discuss in Master Black Belt on why adjusted R squared. But for now, remember that we will look into R squared. 44.15%, that is 44.2 approximately. This indicates that 44.15%, 45.15% of the variation in sales is explained by variation in promote or ad promotion. 44.15% is explained. You cannot expect a prediction model to explain you 100%, right? Prediction model results cannot be 100% certain. To some extent, it will be correct. Right? What is that extent? Is 44.15% in this model that we have built. All we have done is we have built a prediction model now. So here also p-value is less than 0.05 in regression. What does that mean? It indicates that we accept null hypothesis. We reject null hypothesis. And obviously, if we reject that, we will go ahead with the alternate hypothesis, which says yes, alternate. There is a model. There is a model that exists. All right. Now, let us go to the residual plots. So, what do you look into all these plots and decide? We decide multiple things. First thing is, the residuals are normally distributed. Look at this. They're falling exactly on the line. If they're falling exactly on the line, you straight away say that data follows normal distribution. Here, if you see, there is no fan pattern, which means residuals are more or less constant, right? There is no pattern actually here. They are randomly distributed. They have to be randomly distributed. You have to check all these things. Look at this histogram. There are not many extreme values again. There is no extreme value. Right? Again, this indicates that residuals are normally distributed. And look at this last one. There is a random pattern. There is no particular pattern, right? Everything is random, which shows that residuals are not related to time order. So as and how time increases, my residual count increases, right? Such kind of thing is not there in this. So they are stable and independent. So by looking into these 4 graphs, you can comment all those things. Now all this while, Anuj, I have been making a statement called residual. Residual. Always I was making a statement called residual. What is residual? So in that regression equation, we have sales. Let me go to that. Here we have sales equal to so much, right? So if I put my promotional ad expenses here in this equation, I'll get sales, right? 1 month down the lane, I want to invest some amount on my promotional activities, which will give me sales. That is my predicted value. I'm predicting 1 month from now what is going to happen. But after 1 month, I'll get to know the actual value, right? Today, if I want to predict after 1 month, that is called as predicted value of sales. But if I wait for 1 month, I'll also come to know the actual value. The residual is nothing but it's a difference between observed and predicted Y. So after 1 month, I get to know the observed value of sales. Today, if I want to predict after 1 month, that will be called as predicted. What is the difference between these two is called as residual value. Yeah. These things we have discussed. So these 4 residual plots that we have seen, which will it's going to help us whether the model meets the assumptions of the analysis or not. Histogram, it should not be skewed or there should not be outliers. Skewed and all we'll discuss in MBB in detail. Normal probability plot. So yeah, for last example, we are concluding that yes, the model exists and I've built a prediction model. The equation for the prediction model is this regression equation. So from now on, if I want to know what will be my sales, from now on, if I want to know what will be my sales, I can put my promotional ad expenses in this equation to predict my sales. So I've built a prediction model using a simple equation. It's called a simple linear regression. Yeah. Then we have looked into normal probability plot, which indicates whether data are normally distributed or not, whether the other variables are influencing the responses or outliers exist in the data or not. Then comes residuals versus fitted values. It indicates whether the variance is constant, whether a nonlinear relationship exists, or whether outliers exist in the data or not. Then comes residuals versus order of the data. It indicates whether there are any patterns in the data due to time or data collection order. Alright, in the example, residues are normal except 1, 2, there were only 2 extreme values. If I go back here, I can show you this is one extreme value and this is one extreme value. That's it. Right, residues show no defined pattern and the model is acceptable. With that we proceed. Regression analysis, that equation that you have seen, sales is equal to some number multiplied by some number, this equation that we have got. It's based on this. It is an algebraic representation of the regression line and is used to describe the relationship between response, that is sales, and predictor variables, that is promote. Response Y is equal to, this is how the equation will be. Here we had only sales and promotional activities, right? If you have 5, 6 other X's, then this is how the equation would look like. Always this B naught or beta naught is considered to be constant. It is a value of the response variable when the predictor variable is 0. That will be a constant. Constant is also called as intercept because it determines whether the regression line intercepts or meets the y-axis or not. In your MBB will be doing a lot of deep dive on this. It will not be I mean there won't be things like your black belt or green belt will be entering into a different orbit altogether. Alright, predictor X is the value of the predictor variable, this X. The coefficients are the change in Y that occurs when respective X increases by 1 unit. So those are again coefficients are calculated. If B is positive, then as X increases, Y increases. If this B is negative, then as X increases, Y decreases. So B, I am referring to B1, B2, B3, B4 until Bk. Now from a previous example we got this. This equation can be used to predict the sales for a given value of promotion activities. Then we have also seen R squared value. R squared value represents the proportion of variation in the response data explained by predictor. In our previous example, R squared value was 44% approximately, right? So 44% of your sales is explained using your promotional expenses. That is what you say. Now R squared describes the amount of variation, which we have already discussed. Yeah, we will do that, Anush. We will do that. So there is another thing called as adjusted R square. Adjusted R square is nothing but it's a modified R squared value. Yeah, that has been adjusted for the number of terms in the model. For example, you might have sometimes unnecessary terms, or you might have unnecessary excess. Then this, if you look into only R squared value, it might be high. But your R square adjusted is going to consider all these factors for deciding on the model. And the general thumb rule is it should be 70% or more for the good model. 70 or 80%. Normally it is 70% that we consider. All right, Anuj. That's it. This, you anyways know this p-value thing. So I'm going to stop here. And I think